notes for AP Calculus on the topic of infinite geometric series. And this is the second part. Some problems that are a little bit different. It says find the common ratio R and determine the x values for which the series converges, and then find its sum. So notice what's different about these, you might be used to just having geometric series that are just constants. In other words, pure numbers, no variables. But you can also have geometric series that have variables in them. In this case, you can see there's x's in them. So let's see if we can figure out what the pattern is. When you go from here to here, or here to here. Well, look at the numbers out in front. It goes 5, 10, 20. So it seems to be multiplying by r. So start multiplying by 2. So part of r would be 2. But notice also what's happening. We've got x minus 1, x minus 1 squared, x minus 1 cubed. So notice we keep multiplying by an x minus 1 as well. So r would actually be 2 times x minus 1. That's what the common ratio is. That's what it keeps being multiplied by. Or the other way to figure it out, you can also take one term and divide it by the previous term. So you can take 10 x minus 1 squared divided by 5 x minus 1. See, 10 over 5 is 2. One of the x minus 1s reduces out. So you get that. And you get the same result if you did 20 x minus 1 cubed divided by 10 x minus 1 squared. So that's, you can tell it's a common ratio. This keeps being multiplied by the same thing. So for this to converge, remember r has to be between -1 and 1 for this to converge. So let's go ahead and put r here, which is this expression between -1 and 1 to determine the x values for which the series converges. So if we say -1 is less than 2 times x minus 1, which is less than 1. And then we want to solve this for x. So there's a couple ways you can do this. You want to isolate the x in the middle. You could distribute out the 2, or what I'm going to do is just divide by 2 first. Either way, you get the same answer. The answer is divide. There's 3 parts to this compound equation, so you divide all of them by 2. So I give you -1/2 is less than x minus 1, which is less than +1. Now we just need to get x by itself by getting rid of that -1, so we can add 1. Adding 1 is the same as adding 2 halves. These have a denominator of 2. We get a common denominator, make it a little easier. -1/2 plus 2 halves is +1/2. Plus, and now the x is in the middle by itself. 1/2 plus 2 halves is 3 halves. So these are the x values. So here's our first thing we ask for is to find the common ratio. These are the x values for which the series converges. So notice that tells you any x values that we were to plug in here between 1/2 and 3 halves would cause this series to converge. But if x is not between 1/2 and 3 halves, this series would diverge, not converge. Okay, so let's say x is in between -1/2 and 3 halves. Then we can find its sum. And the way you find its sum on an infinite geometric series, recall, is the first term, a sub 1, over 1 minus the common ratio. In this case, the first term, a sub 1, is 5x minus 1. So let's just go ahead and simplify that. So we've got first term, 5x minus 1, over 1 minus the common ratio we figured out is 2 times x minus 1. Well, be careful on your simplifying here. Some common mistakes that may be tempted to do would probably be mathematically incorrect. The first thing that would be incorrect is to reduce out the x minus 1s. The reason why you can't do that is because the number has 2 terms because it is 1 minus 2. You can't reduce those. You also can't subtract 1 minus 2 and make that a -1. It's tempted to do that because then you'd be subtracting before multiply, which violates the order of operations. So to simplify this instead, you would just distribute out the 5, so that'd be 5x minus 5, and distribute out this -2. So you'd have 1 stay there, and then minus 2x, and then plus 2. And then just combine your like terms on the denominator. So we get 5x minus 5 over 2 plus 1 gives you 3 minus 2x. And you can see we can't reduce anything out there. that one. So that would be the sum. If x is between 1/2 and 3/2, you put that x value here, and that would give you the sum of the series. But of course, this only applies if x is between 1/2 and 3/2. Because if it doesn't, x is not between 1/2 and 3/2, the series is not going to converge at all. Okay, so this wouldn't apply. This only applies when the series converges. All right, so we'll go one more of these with some variables in there rather than just constants. So let's take a look at this one here. We've got 2, -8x minus 3, positive 32x minus 3 squared. So let's see if we can figure out the common ratio on this one. Let's look at the numbers first. 2, -8, positive 32. Notice it's alternating between positive and negative. So r has to be negative, and what it's being multiplied by is 4. 2 times -4 is -8. And then -8 times -4 gives you a positive 32. So when it's alternating, you can see r is negative. And we've got this x minus 3. It doesn't appear in this one. Here's being multiplied by x minus 3. Here's being multiplied by another x minus 3. So it'd be -4 x minus 3 would be our common ratio. Again, you can also get that by just taking one of the terms divided by the previous one. So we took 32 x minus 3 squared divided by -8 x minus 3. You can see negative 32 divided by -8 is -4. When x minus 3 reduces out, you get the same thing. You get the same thing if you take -8 x minus 3 divided by 2, it would just be -4 x minus 3. So that just confirms that it is a common ratio. And again, for this to converge, this common ratio of r has to be between -1 and 1. So you can see -1 is less than -4 x minus 3, which is less than. And again, here you could distribute out the -4, but it's probably a little more efficient to just divide everything by -4 first. All three parts of the inequality to be the true. The -1 divided by -4 is positive 1/4. Remember, when you divide by a negative, you have to flip the inequality sign. In this case, there's two of them, so it becomes greater than. Now we're just left with x minus 3 here, and that's greater than -1/4. And then you can add 3. But adding 3, since these are in fourths, let's get a common number. 3 is the same as 12/4, so it's like adding 12/4. So 12/4 plus 1/4. So we get 13/4. And it's greater than x, which is greater than 12/4 minus 1/4 is 11/4. So you could leave it like that. That is correct. Oftentimes, though, you'll see these compound inequalities are written from low to high because that corresponds more to the number line. So you could also write this as 11/4, but the sign is less than x, which is less than 13/4. So that's where x values, pretty small range there, where this series would converge. And then let's go ahead and find the sum if it does converge. Again, the sum is the first term, a sub 1, over 1 minus the common ratio of r. This time the first term was just 2. So that's 2, there's your a sub 1 right there, over 1 minus r we figured out as a -4. So then minus a -4 actually makes it a positive 4, and then x minus 3. And then if we distribute out the 4, we get 2 over 1 plus 4 times x is 4x, 4 times -3 is -12. So if it does converge, the sum would be 2 over, my like terms, -12 plus 1 is -11, so 4x minus 11. So x was between 11/4 and 13/4. You plug in that x value right here, and that would give you the sum of the infinite geometric series. That concludes the notes for AP Calculus on the topic of infinite geometric series with variables.